Ooh, let me see. Where am I getting sound from? Ah, bam. All right. So that's all that's all number one wants is just what's important in this problem. Okay. Can you do, what's number two? What would be used to figure out number two?
The usual speed that it's 39
This whole thing right here.
45. Yeah.
Now, how the hell are you going to do that? So make the numbers nicer. What if 80 miles took 60 minutes? How fast is that? Does this have anything to do with the problem?
80 miles an hour?
Yeah. This has nothing to do with this problem, but it is helping my brain work with the weird ass numbers they gave me. If the numbers were nicer, why is this easy? Because 60 minutes is an hour. And then it's 80 miles divided by how many hours? So if only this was, look at this smooth transition to making a different color. If only that was hours, what would I do with the numbers here? What would I do with the numbers here to get the speed?
So the 39 divided by 0.75
Don't go
hours?
that far. You would take 39 miles divided by whatever the hell, if only this was in hours. You guys have got to start figuring out. So the problem is not a hard one. It's they just didn't give you hours. Damn, they didn't give me hours. All right, so make them hours. But the first thing you have to realize is, man, if only they would have given me hours, that would have been an easy problem. Okay, then make them hours. Make the problem easy. But if you don't take a second and realize that's the one thing that's in your way, you're not going to know to do that. Does that make sense? No? No. Screw you, Jeff.
So would it be 0.75 hours?
Yeah, 3/4 of it. So watch, you can even do this, 39 miles in 45 minutes. You could even do this if you want to. Change minutes to hours. Wouldn't that make it into miles per hour? You could even do that if you want to. And that's where the 0.75 is coming from. Okay, maybe. But that's the point of a lot of these problems is, okay, the numbers they give you are gross. The units might not be right, but that doesn't change what you want to do. That adds steps. Oh man, I got to make this unit become this. And the numbers are gross. So I got to figure out, do I divide or multiply or what do I do? But in the end, you're going to do the same thing if the numbers were nice and the units were right. You're going to do the same thing. So that's why I like to do this. If they would have told me it was 60 miles in 2 hours, then that would have been how many miles an hour? That would have been 30 miles an hour. That's easy. And then I just go, okay, I don't have hours. That's step one, make those hours. Step two, I divide once I get that. Then I'm done. Then you have a plan of attack. You have steps to take. The problem will not always tell you the steps you got to take. That's a part of the problem, is figure out the steps you got to take. Are you guys semi with me? So people go into math problems with certain expectations. Oh, there's a formula for this always. Oh, they're going to tell me exactly what to do with these. No, they're not. They're not, because that's not real life. Holy shit. Right? So you got to, what do I do with the stuff they give me? And are the units correct? That's like the two most basic things to stop and think about. Maybe? No. Screw you, Jeff. Make these easier. All right. All right, guys. Anything else from 3.5? Oh, yeah, there was something. What was the question? I can't remember now.
Just number 4, just how to set it up.
I'm going to clear all this away. Here it goes. It's gone. It's going away. Bye. Okay. Oh yeah, number 4 is nifty. You see who's up there. Bam. Don't hear somebody putting the groceries away or whatever. Blah, blah, blah. So you don't have to research it. I don't know if anybody looked that up. Barkley marathons. It's not running like Charles Barkley, by the way. Just in case you thought maybe that's what it was. 5 loops of 20 miles. Now look what I'm doing. I'm scanning through it, and that sounds like it's going to be important. Through the mountains of Tennessee. Tennessee is not important. Right? Could be anywhere. I don't care. For those who make it to the last lap, the racers go in alternate directions around the course, which of course means they'll meet in the middle somewhere. Let's say that only 2 racers make it to the last lap, and it's close. All right, so to be honest, here comes the important stuff now. Both start the last loop around the course at the same time. So now watch. So all right. So I started circling things I thought were important. But here's where the really important stuff starts to happen. It doesn't even matter how many racers. It doesn't matter any of that stuff. If one averages 2 miles an hour and the other one averages 1.92 miles an hour, how many hours until they meet? Okay, I love this shit. Oh, this is not an easy problem. You've got to just understand it's not easy, which should take a little anxiety off yourself, right? This is not a directly easy problem. But does everyone understand? Once they get to the last lap, they go in different directions. So I've got this loop. Let me try to draw. Let's see what happens. Here's Jeff trying to draw. Watch out, everybody. All right, not too bad. So one racer is going this way and the other racer is going that way. And they're going slightly different speeds. So if this is the one going 2 miles an hour, say this guy's going 2 miles an hour, and this guy is going 1.92 miles an hour, will they meet right here? Right, so they start right here. Are they going to meet right halfway?
No.
Can anybody tell me, are they going to meet right of this or left of this? Did I say that right? No. Left of this or right of this?
Right of it.
Yeah, they're going to meet a little bit over this way, aren't they? Why? Now, does this have anything to do with answering the question? Not really. But this is just, I'm going to make sure I understand what the hell this question is about. So it's all about where they meet. So why not take a second and figure, okay, where does it make sense? It makes sense they're going to meet a little bit over there because this guy is going faster. So he's going to make it further. This guy's not going to make it as far. They're going to meet more on this side. Does that by itself make sense? Can you do this problem without even thinking about what I just said? Yes. But, I'm like, what's physically going on here? What's making some sense? Why wouldn't they just meet here? Because, one's going a little faster. Now, how long is it all the way around the loop? Isn't that another important thing to know?
Well, the whole thing's 100 miles.
Yeah, this is kind of weird. I might have to look it up, to be honest, because 5 loops of 20 miles. Does that mean each loop is 20 miles, or does that mean 5 loops of 20 miles total? I don't know.
I said the same exact thing, but I looked it up and it's 100 miles.
Okay, thank you. Maybe that's one reason to look it up. So they got one loop, and that's what we're talking about, is the last loop. All we're talking about here is the last lap. So we're working with 20 miles, right? So all the way around this is 20 miles. Don't worry. I know it's a circle. That doesn't really matter. It's exactly the same as if one starts from one end and the other starts from the other end of a 20-mile thing. It's exactly the same problem. It doesn't matter that it's circular. All right, let me stop for a minute. Oh, somebody's plane's coming. Oh, there he goes again. Is somebody at a airport? What's happening? All right. Now again, I need you guys to get off your back a little bit. this problem is not straightforward. It's also not impossible. It's nowhere near impossible. It's just, did we do an example like this? No. Do I care? No. It's all about, can you stop and think and draw? I don't know if anybody thought to draw themselves a little picture. See how I'm doing this. I don't even think about what I'm doing necessarily, but it's 20 miles total. That's important. I put down the speeds they're going. That's important, right? That's why that first problem was all about what's important and what isn't from what they told you. You all know that problem where they say, take 7 dogs and the 7 doesn't matter, but you try to throw it in the equation anyway, right? So it's that kind of thing. You got to be careful. Don't just think every number's got to be used. No, who knows? Now, the neat thing comes. This is what I want you to realize. All right, let me see. Sure, we can do it with these numbers. So let's say this is the 2 mile an hour one. This is kind of a neat thing to realize is it doesn't matter that if it's a circle or not, but let's just work with a circle in case you didn't realize you could make the circle straight. Stay with me now. After 1 hour, how far has this guy gone?
2 miles.
2 miles. Right, so let me just give myself some stuff. And so after 1 hour, how far has this guy gone?
1.92 miles.
Yeah. All right. Now think about this. Now, obviously, they haven't gone all the way around. They haven't met yet, right? When do you know they meet? That's the important thing. When do you know they meet? Is it when they each go 20 miles? Would that make sense?
When the sum of their two distances add up to 20.
However far this guy goes, plus however far this guy goes, has to be 20. That's when they'll meet. Does that make sense? If together they haven't gone all the way around the circle, then obviously they're not going to have met yet. They're going to meet when together they've gone 20 miles. So now, do I know how long that's going to be? Do I know how long that's going to take? That's the whole point here, right? Is to figure out how many hours it's going to take. So what am I going to call that? What am I going to call time? I don't know what it is. T. I love it. You can call it T. You can call it whatever. And by the way, if you make your T's like this, you're going to want to stop doing that because they look like plus signs, right? That's why I've naturally made T's like this now forever. T kind of sucks, but T is actually a decent letter for me. S is a bad letter for me because it looks like 5. After T hours, how far has the speedy little dude gone?
2T.
2T. After T hours, how far has this not so speedy little dude gone?
1.92T.
1.92T. And like we just said, I want the distance they've traveled together to be 20. I have no idea why I just did the whole problem for you, but I did. So enjoy that. That's the last one I'm going to do for you in this problem. So at least now you have to solve that equation. Oh, they actually give you this. What do their distances have to add up to be? I didn't even notice. They give you a giant hint. Good Lord. When they say hint, pay attention. But all right. Is that a set type of math problem? Not really. No. It sort of is, but not really. You got to make your own equation from what they tell you, set it up and solve it. So if you are wanting an example to just do exactly the same thing, just with different letters and numbers, no, it's not too bad. Too bad. You got to let that go. But also don't put so much on your own shoulders. These are not simple. I'm not saying you can't do them. I'm just saying don't think you're going to get it right away. All right. I don't know how else to say that. So I think people give up because they feel like for some reason you think, well, I can't do this after this many minutes. I must not know what I'm doing. Or no, what? No. You're not used to doing the stuff I know how to do because I've been doing it forever. I make easier numbers. I draw pictures, right? So you can start doing the same thing. Okay, maybe. So realize that this problem being a little more difficult is not a bad thing. It actually should take a little pressure off of you. Don't feel bad if you can't do it immediately. It's supposed to be challenging. Just don't give up after 2 minutes. Okay, maybe. Is that a good pep talk? Just don't give up. All right. Anything else from this section? Let me see.
You should do it in a macho man voice, though.
Oh, God. Oh, brother. Oh. Don't even let me get me started. I used to do that all the time. I'm going to come down from the mountaintop and I'm going to say, don't you give up. Sorry.
Much better.
Thank you. Snap into a Slim Jim. No, okay. That's enough of that. All right, guys. Oh, man. That's taking me back. I was a little kid in the 80s and used to watch. My little brother was really big into wrestling, and I told him it's a soap opera for men, Jim. And he's like, shut up. So I used to just love sitting there watching it with him. Hulk Hogan. All right. Let me clear all this. This is going to all go away. Bye. All right. What else we got? Anything from earlier, 3-4? Any other questions from back there? I had a few questions earlier from 3-4. Or anything else from 3-5 that I won't do all the way through?
Section 346B. I know you were going over it like right when I came in, but I barely missed it.
6B.
In the prep skills.
Oh, prep skills. All right. So this is a great example of making a simpler problem. So let me make a simpler problem. So let's say they can mow 50 square yards in an hour. And so how long would it take them to mow 100 square yards? See, what I also did was I made the units the same. How long would that take? If they can mow 50 square yards in an hour, so screw this is crazy. Let me make a better number. How long would it take them to mow 100? Screw this. Let me make a better number. Does that make sense? It would be 100 divided by 50.
Yeah, that makes
Right.
sense.
All right. Now, so what you do then, so a lot of times students are like, where'd the 50 come from? Is the answer 2? No, this is all on the side stuff, right? Now let me uncross out. Now I've got to use the ugly numbers, but I got 2 things to realize. One reason this was easy is not just because I made nicer numbers. I made the units the same. So you got to, oh shit. Let me take a minute and make the units the same. And then what am I going to do? I'm going to take this and divide it by this, whatever they become after I change the units. How do I know to do that? Because I did it with easier numbers because my brain normally latches on to easier numbers. So I've done that several times where I give myself nicer numbers and then I just let my brain kind of do it. And I go, oh, what did I just do? What did I just do? I divided. Okay, that's what I'm going to want to do with the ugly numbers. Does that make any sense? I mean, that's such a crucial thing to know, but I don't think teachers ever teach that. Not much. No, you guys don't like that? All right. So now you just got to pick. Do you want to make square yards into square feet or do you want to make square feet into square yards? Don't just change both of them. I've had students do that and they kind of like cross themselves in the night. And you want one becomes the other one. Stop. Is that all right? I'll never know. I forgot who was asking me. Is that all right out there?
I think
It's
so. I'm still like a little bit lost. I don't know. Whenever you graded mine, I think I had wrote at the top 12,000 yards squared divided by, what did I write? 60 minutes, and then you circled that. So I was like, okay.
because that would be, I think you're concerned about this. That's not the point. I'm going to leave this alone because then my answer will be in hours.
Okay.
Now you could change it to minutes and then your answer would be in minutes, and that would not be a problem really because it would still be an answer, but there's no need. What I got to focus on is making these the same, because otherwise these can't work together.
So it's 3 feet in a yard where I then just take, oh man, I'm
Here we go.
pricing them.
Here we go.
125,000 feet
Oh,
squared.
I'm
divided
going
by-
the other way. Sorry. Let's go the other way.
Okay, sorry.
So now how many times am I going to have to write this down? Because if I do it once, that takes care of one. So I've got to do it twice. Remember this? Now that kills both of them. And now I'm going to have feet. I'm going to have square feet the way I'm supposed to. So the big mistake people make is they only do this once. You got to do it twice because you got two of them. And then you fill in 1 yard is 3 feet. 1 yard is 3 feet. No? Is that right? The thing
Yeah.
to remember is that relates to this, and the thing I'm doing right now relates to that. So I'm going to take 125,000 divided by whatever I get here. So the whole purpose of this making nicer numbers is to know what to do with the uglier numbers once they're ready. So once I get the numbers ready, I know I divide this guy by whatever I get from here.
Okay,
Maybe.
that makes sense.
Okay.
Thank
And
you.
again, why is it okay to do this? Because it's not a part of my answer. And if this is 100 and this is 50 and I divide, if this was 200 and this was 50, I would still divide. If this was 8,000 and this was 500, I would still divide. The thing I do doesn't care what the numbers are. That's why I can do that. That's why I can make nicer numbers and go, oh, I want to divide. All right, let me get the ugly numbers ready, and then I'm going to divide them. I really want that to make sense because people feel like that's cheating or they think this is the answer. No. Somewhere in between there. Okay, so I want you to realize when I say that some of these problems are not easy, that's not to make you feel bad, it's to make you get off your own back when you're having some trouble, right? Because I think we give ourselves some shit when we don't live up to expectations. But how do you know what your expectations are? You don't know. That's why I try to tell you. Some of these are not easy. Oh, great. It's calling me. Am I shaking? No. Okay. A little bit. All right. Anything else, guys, from homework? Oh, all right. How about the quiz? Did you guys all take a look at your quizzes?
How do I get the Zoom meeting to?
Sorry? Oh,
Sorry, I accidentally logged out.
okay. All right. So let me remind you about something, guys. Let me see if this makes sense. So you know when you take a quiz, you go to access the quiz, and then you turn it in somewhere else, right? You with me? When you go to access the quiz, so let me pull this up for you to see. Oh, where are you? Here you are. Hold on, give me a minute. Let me get to the right place. Okay. Let me share this. Oops, shit. Where is it? There it is. All right, so when you go to your quiz, it's not gonna look like this, but I don't care. You get your quiz. Here it is, right? Let me be a student here for a second. Hold on. Student. Then I can go to my quiz like normal. Quiz. I really want this to make sense. The reason I ask you, when you go to take the quiz, got the evil little time going, but when you go, I wanted you to type in done at 8:14 a.m., whatever the hell, right? Done at 8 a.m. And then you hit submit. And what that does is it shows me on my side that you accessed your quiz. Because did everybody have these problems? Did everybody have something about a candle being lit on the first one? No. Some of you guys had a hiker going down a canyon. There are different versions of the quiz. So if you don't do this, if you don't hit submit quiz, it takes it up to 2 days to close that out so I can see which version of the quiz you had. Do you understand? So some of you guys, I graded yours this morning because it finally showed me which version of the quiz you accessed. So if you don't do what I ask you to, that leads to trouble. So I did have somebody cheat in another class early on. They just copied answers from somebody else, and I could see that they had the wrong version of the quiz. It didn't match up with their answers. Are you guys all with me? Not a very smart move. I'm like, if you're going to cheat, it takes some thinking to cheat correctly. So I'm a little on edge about making sure that the answers you give come from the quiz you got. And if I can't see which quiz you got, I can't tell. So I'm finally better about I didn't realize it took it like up to 48 hours to release that, to just say, oh, they must be done. And let me see. Is anybody with me? If you have no idea what I'm saying, just do what I ask you to do. Just actually fill this in and hit submit there, right? That'll make it show me which version of the quiz you had. I hate accusing people of cheating when they really didn't. I don't want to do that. I'm trying to be better about that in general. I know most of you guys are honest. It's hard enough already trying to keep up with this online shit. And you don't want me throwing extra things in your way just to kind of keep the cheaters at bay. I don't want to do that too much. Okay.
Yeah. Okay.
Okay, cool. So guys, anything else from homework stuff? Or anything from the quiz? I don't know if you've taken a look at the quiz.
No, I think you covered pretty much a bunch.
I did, I know. I just want to make sure I covered enough. In conclusion, do not cheat. Yes, that is the simple conclusion to reach. Okay, so if there's no more questions, we're going to go back into where we left off. Let me see. So you desperately, if you haven't gotten to section 3.5 yet, do it tonight. Have some questions tomorrow. We're getting into 3.6 because we're crazy. 3.6 is going to be, it's interesting. I don't, so the terminology they use is correct. It's just unnecessary. So here's it's not unnecessary. How do I say this correctly? It's not integral to doing a problem. So I don't know, has anybody ever heard this phrase before? Directly proportional to? So what that means is, so you can have direct variation, and there's also something called inverse variation. So directly proportional to, so if the amount of money you make is directly proportional to the number of hours you work, I can set up an equation like this. All right, now this is gonna, see if ever, the amount of money you make is directly proportional to the amount of hours you work. Now let's see if you guys can step outside of the math for a second. What the hell would K represent? So the amount of money you make is directly proportional to the amount of hours you work. What is K in real life?
Your wage per hour.
Yeah, the amount of money you make an hour. So if I'm making $15 an hour, this would represent the amount of money I make if I knew how many hours I worked. That is an example of direct proportionality. Ooh. Otherwise known as direct variation. So something to realize, can anybody tell me two things about this? What is the slope of this? And what is the y-intercept of this? All right, let's start with an easier problem. Look up here.
Slope is 15.
Yeah. Slope is 15. So like here, the slope is 2. What would the y-intercept of this equation be? So this slope is definitely 15 because that's in front of the variable. What's this guy's y-intercept?
5.
Careful.
Zero,
Y-intercept.
5.
Yeah, there we go. Sweet. I love it. I know that seems like I'm just being a picky jackass, but intercepts are points. Points have 2 parts. So what's the y-intercept of this guy down here? What's this guy's y-intercept?
0, 0.
Exactly. They ain't shit there. So it must be 0, 0. If I put a 0, if I work 0 hours, how much money are they going to give me for that? 0. So this idea of direct variation or direct proportionality requires you to go through the point 0, 0. Otherwise, it's not directly proportional. We got that extra little bit, right? That's plus 5. So am I always double X? No, I then add 5. So it's not directly proportional to. Now, let me stop for a minute. So I'm not as concerned about the terminology as I am about the idea. So let's look down here. This is a good example down here. Exchange rates of money. I'm going to clear all this. Go away. So let's see what this says. Let's see. Ooh, interesting. What are they talking? Okay, in Russia it was just 215. All right. U.S. exchange rate for Canadian currency is 1.2. It means that you could trade $1 US for $1.20 Canadian. The Big Mac cost mentioned earlier. Average cost in the U.S. was $5.06. In Russia, it was just $2.15. And in Norway, the cost was almost $6. Dude. Oh, all right. This is interesting. So we were supposed to look this up. Well, let's look this up. Why not? Here, let me share something else. Now I'm curious. Now I want to know. I have no idea if you guys share. I want to know how many rubles are is $1. So let's take a look here. Shit. Let me put you guys back over there. Bam. You see, do I have anything weird open? No. So if I say 1 ruble to US, 0.013. So let's go the other way. What's $1 US to ruble? Yeah. All right. So $1 US right now equals 76.24 rubles. All right, let me write that down and then I'm going to stop sharing. Oh, there we go. Yeah, perfect. All right. Hold on. Give me a second. Well, shit, I can't do this, can I? Dadgummit. All right, so 76.24. Just got to remember that. Let me move you guys back over
That's
here.
equal to $1 US, right? Not 1 ruble.
Yeah, $1 US is
Okay.
76.24 rubles. That's how they wanted it. 76.24 rubles. I like it. I like it. Now, number 2 is really just taking us back a bit. Conversion factor with US dollars in the denominator. That would just be there's 76.24 rubles in $1 US. Right? Could have been the other way around for the same conversion factor. It just depends on which way I'm trying to convert. So if I wanted to write now, I think this is eventually going to get to this point. If I wanted to write an equation that was rubles equals K times US dollars, What would K be?
$76.24, right?
76.24. Every US dollar is 76.24 rubles. So this is directly proportional. The number of rubles is directly proportional to the number of US dollars. So this is I want you to realize this should feel very familiar. See this table down here? This is just plug shit in, right? So this first one would be R equals K times 0, which makes sense. You got $0, you're going to get 0 rubles. There's no conversion in any country that you come up to the counter and say got 0, and they're like, well, here's 5. No, it doesn't have. They're like, that's nice. You ain't getting nothing from me. Why did I put a K there? Dadgummit. 76.24. So now to do this one, it would just be 76.24 times 10 and so forth, right? We've done that before. What the interesting thing is, the equations are actually a little nicer when they're direct variation because there's no y-intercept. Or, the y-intercept is 0, 0. So there's no plus b. All right. So I'm not as interested in doing this table and this graph. That's old news for us. We should be able to do that pretty easily, right? This step here and then graph them, easy. The slope we already talked about. We already made an equation because we're ahead of the game here. Let's see, blah, blah, who cares? All right, let's try some of this. Oh yeah, cost of taking a cab. Yeah, is this an example? Was that equation, let me put it up here again. So does this equation look familiar? It was 5.1 plus 2.6 m. Is that direct variation? Let's see who has been paying attention. Why not? It definitely isn't, because what's there that should not be there? Or what's got a value that's something that it shouldn't have?
B.
Say it again.
B.
Yeah, okay. I see what you mean. So this 5.1, the y-intercept is not 0, 0. So let me do this, just to make sure everybody's with me. I'm going to make a series of equations. All right. Which ones of those equations have an intercept of 0, 0? Don't say anything out loud. Hold on. Think about it for just a minute. Which ones of these equations have a 0, 0 intercept? All right, go ahead and tell me.
2 and
2
4.
and 4.
Yeah, this one and this one. Because when I make this variable 0, what's the other variable become? 0. So those two are officially direct variations. Because this variable varies directly as that one. Does this variable vary directly as this one? No, there's a little extra thrown in. That's why we don't call it direct variation. So again, I keep saying it because I do want you to get used to it, but the words don't matter as much, really. But the type of thing we're talking about in this section involves a y-intercept of 0, 0. And to be honest, that's obviously also an x-intercept. Right? Isn't that the one place where it's the x and y-intercept is the one that intercepts both axes at once, which is 0, 0. That's crazy. All right. So this looks like a little dude to me. Oh, yeah. All right. We live in the state where this is the most true. It could be. I think Hawaii also is in the bad place with gasoline. Do you think the amount spent at a gas pump and the number of gallons of gas purchased are things that vary directly? What do you think? If they didn't, that would mean that if I didn't buy any gas, I would still have to pay something because it wouldn't go through the 0.00. But if I buy no gas, do I have to pay the gas station anything for the gas? Don't come at me with, well, I bought some Oreos. Be quiet. If I went to a gas station and then decided I don't have time to get the gas, and then I just drove away, are they going to come chasing after me? Wait a minute. You owe me $20 just for driving on my property. No. Are you guys with me on that? So this one, obviously, the amount I spend at the gas pump depends directly on how many gallons I get. If I get no gallons, I owe no money for gas. All right, that's kind of silly. I agree. I'm going to clear all that away. By the way, I never did answer this number one. I just realized maybe we did. Is this direct variation? No, I guess we didn't. That's right. That's right. We answered. So make sure I actually answer that question. Let me see. Do I really have to go through all? I think considering, yeah, here we go. All right, this is kind of silly. This is basically the thing I just said about Oreo cookies. I don't want to add a note. I don't want to add a note. Okay. If 5 gallons of gas costs $11.10. All right. Can you guys write, before we even do number 4, can you right here just write, let's agree to some terms. What do I want to say? The gallons of gas we'll call G, and the cost we'll call C. That's going to be, oh boy, it's going to be troublesome. Can you write something involving the letter K that shows me how these are related to each other directly? Do it. I'll sit here. Just like we did a minute ago. So let's see what you got. The cost. How would this go?
K times G.
K times G. I love it. Now, I'm sure you guys would have different ways to do this problem, but now I have kind of a nice way to do this. If C equals KG, and I know that 5 gallons cost $11.10, can you throw that in this and solve for K? I'll sit here. It's actually not the point to number 4, but I don't care. We're just going to screw the number 4 because number 4 is too easy. They are taking a long ass time to get to the point, so I'm not going to do all that. We are getting to the point right now. Why not? We've done this kind of thing before. So how would this work? What would you put in place of C? So they give me this situation here. 5 gallons cost $11.10. What would you put in place of C?
$11.10.
Yeah, because C is the cost equals K times the gallons, which is 5. So can you solve for K? Can you figure out what the K is? This is obviously a different state, or it's our state in a different time. What do you guys get?
$2.22.
$2.22 a gallon. I like it. I can't quite remember the last time it was $2.22 a gallon here. All right. So therefore, in general, what is this equation? Well, I know what K is now. So C would equal 222 times G. So this models how much money I have to pay if I knew how many gallons of gas I was going to get. So obviously, if I'm like, I need a bunch of gas, and all right, this is Jeff coming home, and I had no money on my debit card, and I had, I think it was $6 and something in change that I rounded up for my car. So I would do $6 and something equals 222, and then I can figure out how many gallons of gas I can get, right? If I divide by 222, and I can say, do I think this is going to get me home? So I'm like, I had to call up a friend and say, listen, I might only make it this far. Can you come pick me up? And I made it home. Thank God I was on fumes. Anyway, it's an exciting time. All right. I think you guys are with me on that. So a lot of this is repeat. We've already worked with equations. We've already worked with linear equations. This is actually just a kind of like a subset of linear equations, ones that have b is 0. All right, let's do this. Let's see what the, yeah, it takes them forever just to get to the point we just got to. Blah, 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 blah. Blah, blah, blah. Let's look at what the homework is going to look like. Well, let's see here. Oh, yeah, I like this. This is the different version of the same question I asked earlier. So instead of giving equations, they give graphs. Take a minute and figure out which of these has y varying directly as x. There really is only, given that it's a linear relationship, there's only one requirement. Which one of these is not a direct variation example?
24.
Yeah, because the only one requirement we hold is that it goes through 0, 0, and this don't. So these are, even though this one has a negative slope, who cares? It's still varying directly. You have vary directly and you have vary inversely. And that's, we're not going to talk about inversely. All right, so I kind of like that one because it was graphically not in equations. So let's take a look at what the homework's going to look like here. Yeah, all right, I like it. So they have a problem like we did with the Russian rubles. So now you, if you were paying attention, I don't know if you've never done this, but you go to Google and you just type in $1 US equals yen, right? I always try to say yen. And then you can do the table like we talked about earlier. You're going to have the equation. And then number 3, they have the equation, but you're probably going to, I would have the equation up here already. Now here's something to remember. You guys remember this? We did talk about this a little bit before. Which one is the independent variable? So are US dollars or Chinese yen? Which one is the independent variable?
US dollar.
Yes, and you can tell right there because they don't depend. Not the way I've got this set up. I've got it set up so that these are my inputs. So they are whatever the hell I want them to be. They don't depend on this. The yen depend on, if this is 20, it's different here. If this is 40, it's different here. So this would be the independent, and this would be the dependent. The yen depends on how many US dollars I pick, or I have. All right, let me clear all this. Go away. And then they got some questions about changing something to, you've got the equation. So any question they ask you, like number 5, will be simple. You throw the number in the right place in the equation. So that's the power of equations. They capture an idea and then it can use it for different situations. That's what equations are for. They throw some percentages in there. That should be fun. All right, I don't want to get too deep. Oh, this one looks exciting. I like this. Where are we at? Dubuque? We're in Iowa. Is that Iowa? Dubuque? Idaho? Iowa? I don't know. All right, that's enough of that. That's enough looking ahead. Cool, I like it. You guys want an early day today? Is that all right? Anybody gonna be upset at me if I let you out early? You
Nope.
feel like you're not getting your money's worth? All right. I've had people get angry at me before. You always let us out like some minutes early. I'm really sorry. I think it's enough for today. So tomorrow, come ready with questions from 3.5 especially. But if you get into 3.6, cool. And we'll get into section 3.7. Cool. If you need to hang out, let me know. Do you have any questions?
I do have a question.
Yeah.
So on 3.5, question 2, if we're going to convert it to hours, it would be 39 over 0.75. Hold on a second. Let me get back to the.
Oh, yeah.
Okay.
Yeah, you could do it that way. Sure.
So is that the right answer, or am I supposed to go further with this? Because that's where I'm kind of.
No, that's it. That's it. Number 2 just wants the speed. And if you do 39 miles divided by 0.75 hours, the number you get is miles per hour.
Okay. Oh, got it. Okay. So the number 3 says you should have enough information. And I'm like, I do. So,
You do.
So it's asking you to solve the first question, right?
Yeah. How much time should we have budgeted for the drive home if my usual speed is decreased by 15? Right.
So then I would do 15 miles. So then I would convert that into hours.
No.
Oh my God. I don't know how to.
What's your usual speed? You got that in number 2, right?
Yes. 39 over 0.75.
52. Right?
Oh, 52 equals 52. Okay. Yes.
Miles an hour.
Okay.
You're not going that fast now because your tire got wonked. How fast are you going now?
Oh, you just minus 15.
Yep.
Oh, it's
And then
that
how
easy?
far do you have to go? Huh? Yeah, it's that easy. Yeah.
Oh my God. Okay. And how far do you have to go? Where does it say that? Let's see. Now you should have enough. Oh.
You said that because they break it down so much, which is not a bad idea, but then it makes it seem like it's harder than it really is. So this could have been one question, but they broke it down to several. Just to make sure.
Okay. And then also I was having an issue. I have the hardest time converting things. And when you were talking about question from 3.4, question B on the last one with the feet squared.
The yards. The
Oh
square
yeah.
yards.
Okay. So if I times it 2 times, it's going to be 108,000. Is that right?
Square feet. Yep.
Okay, so I did do that right. Okay, so square feet. So square feet. All right.
You divide the size of the field by the number you just got, right? And that's going to be how long it takes them.
Awesome. Thank you.
You're welcome. How's everybody else? All right. I don't see any questions. I'm going to head out.
Bye.
Bye, everybody.